The SARS-CoV-2 genome is a single strand of RNA with genes that encode fewer than 30 proteins. This is less than 0.1% of the proteins encoded by the human genome. The virus's genome is made of about 30,000 building blocks called nucleotides, which are represented by the letters A, U, C, and G. The unique sequence of nucleotides in a genome determines the proteins it encodes. When the virus infects a cell, its genome is replicated or copied. First, the virus makes strands of complementary RNA called template RNAs. The template RNAs are used to produce copies that match the original virus's genome. This genome replication process is prone to errors. These errors are called mutations. Mutations can occur at random anywhere in the genome. For example, in this mutation, a U was substituted with an A. A nucleotide can be substituted with a different nucleotide, added in the wrong place, or left out. When the mutated virus infects another cell, all the new viruses replicated from it will have the same mutation, plus any new mutations that occurred. Depending on the locations and types of mutations, they may or may not affect a virus's ability to spread in a population. Viruses with mutations that help the virus replicate or infect cells have a selective advantage. These viruses usually become more common in a population over time. Viruses with mutations that make them less effective at replication or infection have a selective disadvantage. These viruses usually become less common in a population over time. Mutations that have no effect on the virus are called neutral mutations. Viruses with neutral mutations replicate just as well as viruses without these mutations. Tracking mutations in viruses can help determine where an outbreak started and how it spread. Understanding how virus populations change over time can also help scientists develop treatments and vaccines.